All right, we're going to be working with chords. What type of chords? A chord is, by definition, a piece of a circle, you could say. A chord is the distance or a line from one point on the circumference of the circle to another, but not including through the center. So let's say that this is the center of the circle. A chord could be from here to here, or it could go from maybe here to here. Both of these are chords. The reason if we were to go through the center it wouldn't be a chord, well, this is then considered the diameter. Okay, so let's just highlight that. This one is a diameter, while our two, which I'm about to highlight in green, let's say, okay, both of these are considered chords. So here is our question. Get a circle again. Actually, just to make the center of the circle easier for me to find this time. There we go. Here's our center. Here is our chord. We're going to tell you that the radius of this circle, okay, this won't quite be a scale, but the radius of this circle, I'm going to say is 2 units. Okay, which then means and I'm also going to give you the distance of this chord. We'll call the chord from point A to point B, and point C is the center. Worked out nice, eh? And we're going to say that this distance here is approximately, I'm going to give it a number, I'm going to say 3 units. Okay, so this is 3 units. And the radius, we'll do it in green here, is 2 units. My question is, what is the distance from C to line AB? So here's our question. How many units is that? Well, there's actually multiple of answers here. I could measure from here to here to here to here, but we're not just going to say in general to AB. We want to know the absolute shortest distance. And the absolute shortest distance will be the perpendicular bisector of this chord. Okay? So in other words, to cut this chord directly in the middle. So if we cut this chord in half, we're looking at 1.5 units and 1.5 units in length there. And we know that the radius of this, okay, let's get a green line again. The radius of this circle is 2. Okay, so if the radius from C to B, that must be 2. We've now built a triangle, and not just any triangle, but a right angle triangle because it has to be perpendicular. That's the shortest distance. So in order to find out, we're going to call this M from midpoint. What is the distance of CM? Distance. Well, we actually just built a right angle triangle. So I'm going to kind of redraw it out here on the outside. Here is our right angle triangle. It's going to look something like this. We have a hypotenuse of 2 units. And we have one of the legs was 1.5 units. So we're going to label this our x value. What is our x? X is the distance from C to M. Well, we can use Pythagorean's theorem because it's a right angle triangle to solve this. We know that the hypotenuse, also known as C squared, is equal to A squared plus B squared. Okay. We know that C is 2 units, so we're going to say 2 squared is equal to, we'll call this side A. It doesn't matter. It could be called side B also for this formula. Is 1.5 squared. Which means our b we're going to replace with the letter x is equal to x squared. So we now have to isolate for x in this question. Well, let's figure out what we got here. We know that this is going to be 4 is equal to 1.5 by 1.5. We'll do that quickly on the side and then verify after. 2, 7, 1, 5 should be 0, 2, 1, 5. 2.25, I believe it should be 2.25. I'm going to double check over here. 1.5. Oh my. That won't go away. Never mind. check that one again after I can do it again. I'm not sure what happened there. 1, okay. 1.5. There we go, 2.25. Excellent. Probably should know that one off by heart. Anyways, is equal to plus, sorry, not equal to, 4 equals 2.25 plus x squared. Now we have to isolate for this x squared, so we're going to move the 2.25 to the other side. So 4 subtract 2.25 is equal to our x squared. 4 subtract 2.25 should be 1.75, I believe, is equal to x squared. Again, we're verifying our calculator here. Let's say 4 subtract 2.25, 1.75, excellent. And to isolate x, well, because it's squared, we're going to need to take the square root of both sides. So we take the square root of both sides. That's going to leave us with x is equal to the root of 1.75. Square root, let's do it like this. Square root of 1.75 is 1.32 approximately. 1.32 approximately. So the distance of CM is approximately 1.32 units. Okay, and we did that by using our property of chords and radius and diameter.